This is Chapter 10, Topic 4. We're going to be looking at Pascal's triangle and the binomial theorem. So this is Pascal's triangle. All right, Pascal's triangle is where you start with 1 and you sum up the different numbers in the triangle to make the middle one. So we start with 1 and 1, 1. Every end row starts with 1, okay? So all of these start with 1, all of these start with 1. So 1, 1, 1, the ends are 1, 1, 1. To get the middle numbers, you add the two ends above. So 1 plus 1 is 2. Okay, then we start with 1 on the ends. This one would be these two added, 3. This one would be these two added, 3. And then we go to the next row, 1's on the ends. These two added gives us this one, these two added gives us this one, these two give us this one, and then we have that row. We're going to use this to expand binomials. Okay, and this is the triangle. You can create this triangle, or you can just reference this. When we're expanding a binomial, I'll show you how to do it in a second, but the row that you're using is the exponent here, okay? So this would be the 0 row, this would be the first row, this would be the second row, this would be the third row here, okay? All right, so how do we use this to expand? So this is x minus 2 to the 5th power, so we're going to be using the 5th row. So 0, 1, 2, 3, 4. This is the row we're going to be using. For each one of these, the power is going to go, so we got x minus 2 squared. So for each one of these, the power of this goes down and the power of this one goes up. So the first one would be, so these numbers here give us the coefficients, okay, of the term. So the first term would have a coefficient of 1. It would be x to the 5th times, so that's this to the 5th, and then negative 2 to the 0. Okay, so that's the first term. The next term is going to have a coefficient of 5. Now the power of the x is going to go down, and the power of the negative 2 is going to go up. So it's negative 2 to the first. Okay, then it's followed by 10 times the power of the x goes down, or the power of this goes down, so goes down to 3. The power of the negative 2 goes up to 2. The next has a coefficient of 10. The power of the x goes down to 2, but the power of the negative 2 goes up to 3. The next term has a coefficient of 5. The power of the first term goes down to 1, and the power of the second term, which is negative 2, goes up to 4. And then the last one has a coefficient of 1. The power of the x goes down to 0, and the power of the negative 2 goes up to 5. Okay, so to figure out what each of these terms are, we just need to multiply. So 1, this is 1. Okay, so the first term is x to the 5th plus 5 times x to the 4th times negative 2 to the 1st. Negative 2 to the 1st is just negative 2. So 5 times negative 2. So that's 5 times negative 2. That's negative 10 x to the 4th. That's the next term. All right, this one, so negative 2 squared, that's 4. So I got 10 times x cubed times 4. So that's 40x cubed. All right, the next term, negative 2 to the 3rd power, that's negative 8. So I got 10 times x squared times negative 8. It's negative 80x squared. Okay, the next term, I have negative 2 to the fourth. That is 16. So I got 5 times x times 16. Five times 16, that's 80. So this is plus 80 x, just x, right? And then the last term, that's 1. So 1, 1, and then negative 2 to the fifth. So that's negative 32. So the expanded form here, if you expand x minus 2 to the fifth power out completely, you get x to the fifth minus 10x to the fourth plus 40x cubed minus 80x squared plus 80x minus 32. All right, let's expand this one. We got 3x, we got negative 2y, and our coefficients are going to be, so we're in the fourth row, 0, 1, 2, 3, 4. We're right here in Pascal's triangle. So our coefficient is going to be 1, 4, 6, 4, and 1. So we got 1 times, so this one, 3x, is going to start at the fourth power, and the negative 2y is going to start at the 0 power. Okay, the next term starts with 4, coefficient of 4. The 3x now goes down to the third power, and the negative 2y now goes up to the first power. The next coefficient is 6. The 3x now goes down to the third power, and the negative 2y is now up to the, no, sorry, that goes down to the second power. And the negative 2y is now up to the second power. Okay, the next coefficient is 4. The 3x is now down to the first power, and the negative 2y is now up to the third power. And now the last one is 1. The 3x is now at the 0 power, and the negative 2y is now up to the fourth power. Okay, so this is just 1. So we got 3 to the fourth, x to the fourth. So 3 to the fourth is 80. So this is 81 x to the fourth. Okay, next we got 4 times 3 cubed, and then times negative 2, and that's x cubed y. So 4 times 3 cubed times negative 2. So 3 to the third times 4 times negative 2, that's negative 216 x cubed y. Okay, next we got, so 6 times 3 squared times negative 2 squared, and then that's x squared y squared. So that's 6 times 9 times 4. So that's 216 x squared y squared. All right, the next one we got 4 times 3 times negative 2 to the third, which is negative 8. That's 4 times 3 times negative 8, which is negative 96, and that's xy cubed. And then the last one, that's 1. We got negative 2 to the fourth, which is 16, and there's no x, so this is just 16y to the fourth. So this is the completely expanded form of this polynomial. Okay, now we can also use a certain formula to help us calculate a specific coefficient of a certain term. Okay, let's say that we don't want to expand the whole thing out. We just want the coefficient that's in front of a certain term. Okay, so we can use this formula up in the corner here. N choose r times a to the n minus r times b to the r, where n is the exponent of the binomial, so right here, and n minus r is the exponent of the term being asked to find the coefficient of. Okay, so it says, number 3, find the coefficient of x to the fourth in the expansion of 2x minus 3 to the 12th. Okay, so we're looking for the fourth power. Okay, so the exponent of the term being asked, n minus r, is equal to 4 in this case. Okay, and n is equal to 12. That's the exponent of the binomial. So we can pretty easily calculate r. Of course, r is 8, because 12 minus 8 equals 4. So now we can use this in the formula. So we got n choose r. So that's 12 choose 8 times a. This is a plus b, so a in this case is 2x, and negative 3 would be b. So it'd be 2x raised to the n minus r, which we know is 4, times b, which is negative 3, and that's raised to the r, which is 8. And this will give us the coefficient of the x to the fourth term. Well, I mean, it'll give us the entire term, and we can use that to find the coefficient. So 12 choose 8 is 495. 2x to the fourth, so that's 2 to the fourth, which is 16 times x to the fourth. And then negative 3 to the eighth is 6561. So we got 495 times 16 times 6561, which is, so we got 519,63120, x to the fourth. So the coefficient of this term is 51,963,120. Yeah. Okay, the actual term itself is this number x to the fourth, but the coefficient of that is just the number in front. All right, so let's do this again. So we're going to find the coefficient of the x squared term. So the n minus r is the exponent of the term being asked. So n minus r is 2. The n is the exponent of the binomial. So we're finding the x squared term in the expansion of 4x minus 3 to the 7th. So n in this case is 7, which means that r is 5, because 7 minus 5 would be 2. Okay, so I can find the actual term by doing I can use this formula. So 7 choose 5 times, a, which is 4x. Okay, this is a, negative 3, this is b. So 4x raised to the n minus r, which is the second power, times negative 3 raised to the r power, which is 5. Okay, so 7 choose 5. That's 21. 4 squared is 16, x squared is x squared, and negative 3 to the fifth, negative 243. So 21, 16, and negative 243. So it's 81,648 x squared would be the term. So the coefficient would be 81,648. Negative. Sorry, I left off the negative on accident. Sorry, that should have been negative. Negative 81,648 because of the negative 243 here.